All right, we are on lesson 4-4, Remainder Theorem. Today's date is Wednesday, November 4th, 11/4/2020. The objective today is to do what, Gunnar?
Use the polynomial remainder theorem to answer questions about remainders and factors.
There it is. All right, so here is the theorem that you need to have. You don't have to memorize the theorem, you need to understand how it works. So the remainder of a polynomial, and I'm just going to call that polynomial p of x, after division by x minus a is p of a. That sounds like Chinese to me, right?
No.
So if I input the opposite, right? So remember when we did synthetic division and you had -3 and then you change it to a +3? Nod your heads yes or no. That's the same thing that's happening here. If I have -7, I plug in 7. If I had +3, I plug in -3. I switch the sign and I plug it back into the polynomial. That will always be the remainder. So it's a shortcut to figure out what the remainder is. Before with synthetic division, you had to do a bunch of steps to get the remainder. There's an even better shortcut if you're just talking about the remainder. And it is plug in the reverse of that into your polynomial. When I say plug it in, wherever you see an x, just plug in that one number that you're plugging in. Which is really cool because if you plug it into your polynomial, if I say x minus 3 and then I plug in a +3 and my remainder is 0, it means it is a factor. That's what I was saying yesterday. If you have no remainder, it is a factor. Let's jump into an example. But P of A, you want to think of this as plug in the opposite. I'll write that down for our notes. Plug in the opposite. To get remainder. All right, so example 1. We don't know what P of x is, but I do know it could be like x squared plus 3. It could be x squared minus 7x plus 10. I have no idea what the polynomial is, but I know these 4 facts. If I divide that polynomial by x plus 8, the remainder is 5. If I divide by x plus 2, it has a remainder of -3. If I divide by x minus 8, the remainder is 7. If I divide by x minus 2, the remainder is -9. What is P of 8? If I plug in 8 into the polynomial, what is the remainder that I should get out? And it has to be the opposite. Yeah, that's right. So which one of it? I mean 8. I mean, it's either going to be this one or this one, right? Which one is the opposite? Make sure you know that. P of 8 is equal to what? And I need to see at least like 4 hands. You're going to guess, right? I mean, is it going to be 5 or is it going to be 7? It's one of those two. You have a 50-50 shot. If I plug in +8 into that polynomial, what should that value be? Andres.
P of x divided by x minus 8 has a remainder of 7.
7, yeah. So the remainder is 7. And another way of saying this, when I say P of A, this is also has another name, another interpretation. The interpretation is the y coordinate or the height of the function. This means the x coordinate is 8. I know what the height is. I know the y coordinate at 8 is 7. So there's this whole two fields kind of converging right now with division and what the actual polynomial looks like. All right, what about P of -2? Lots of hands. Yeah, Jenny. There it is. So -2 turns into a +2, -3. There's the answer. Done. They're that easy. Just remember to switch the sign. I'll also write over here P of A, as I said out loud, this is the y coordinate. So a way to interpret what you just wrote down here is that this point is on the graph. 8, 7 is a point of this polynomial P of x. I know that -2, -3 is a point on the graph of this polynomial that I don't even know what it is. There's a lot of information gained here. Okay, let's move on to example number 2. Ooh, I talked about a graph up above. This is actually a graph problem. Here is the polynomial P of x. I still don't know what the function is, but I'm curious. If this polynomial is divided by x plus 3, What is the remainder if I divide p of x by x minus 5? Oh, sorry, there's two different questions. What is the remainder when I divide by x plus 3? And then secondly, what is the remainder when I divide by x minus 5? So again, take the opposite, x plus 3, negative 3, go to the x coordinate negative 3. What is the height? Charles? 5. Again, opposite of positive 3 is a negative 3. I come to negative 3 right there. I come up to what height? 5. Correct answer here is 5. Let me check. So the remainder is 5. What about when I divide by x minus 5? I, again, don't know what the polynomial is, but I know that when I divide by x minus 5, I know what the remainder is going to be. The remainder is going to be what? What?
4.
4. How'd you get that?
So -5, and you swap it, that's gonna be 5 on the x-axis, and then you gotta go up the y-axis because it's the height, and I got to the point where it intersects, which is at 4. So I think it's 4.
There it is. Again, if you want to do this with circles and stuff in your notes, that might help you. -5, you're going to switch that and it comes to a positive 5. You check what point is on the graph. And he says, oh yeah, that point has a height over here of 4. So the answer here is 4. So height on a graph, the y-coordinate on the graph, the remainder of a polynomial, they're actually synonymous using the polynomial remainder theorem. Example number 3. This time I'm giving you the polynomial. Here it is. It's x to the power 3 plus 3x squared plus 4x plus 7. What is the remainder when I divide by x plus 2? And you could just use synthetic division. That is one way to answer this. If I go ahead and do a -2 in the box in the top left, write the coefficients 1, 3, 4, 7, do all of the math. There's a little shortcut though. If you want to skip right to the very end, the remainder, just plug in something.
There's a shortcut.
Exactly, yeah. What number am I going to plug into each of these x's? And then I'll have a second volunteer tell me how to actually do that math. What number do I plug in for each of these x's? Jade? -2. So let me write it out. That means P, I'm plugging in -2 is going to be, well, it's going to be -2 to the power 3, -2 to the power of 3, plus 3 times -2 to the power of 2, plus 4 times -2, plus 7. And when I say it's a shortcut, it doesn't save you that much time, I guess, in the long run. Maybe synthetic division is even faster, depending on how skilled you are at synthetic division. I need to simplify this. Who wants to help? I'll have you go until you can't go anymore. Say, do I have anyone new? Sergio, you want to take a shot at it? What's -2 to the power of 3? Close. It is negative because negative times a negative times a negative is a negative. It's -8. Perfect. You want to keep going or give it to someone else? All right. 3 times -2 to the power of 2, Charles? Whoa, what? So what is -2 squared?
Oh, wait, 3 times 2 is 6. Oh.
What is -2 squared?
Positive 4.
And then times 3? There it is. So plus 12. We'll give it to someone else. I just will jump around, I guess. What? You want to do the next one?
Sure. Would it be -8?
-8 and plus 7. And we need to simplify all of this together. What have we got? Jade?
12 is 7 is 19 minus 6.
Yep.
So 3.
19 minus 16. You added up all the positives, added up all the negatives. All the positives add up to 19. All the negatives are 16. 3. So the remainder is 3. if I did synthetic division, I should also get 3. You guys want to check that to verify? Let's try it. So mini synthetic division over here. I'm going to divide by, so -2 is going to be in the top left, -2. My coefficients are 1, 3, 4, 7. Draw the line underneath. 1 comes straight down, that's 1, times -2 is -2, add straight down, you get 1, times -2 is -2, add straight down, I get 2, times -2 is -4, add straight down, 3. Pretty cool. Again, you should know how to do synthetic division, but if you want to write it down for the notes, you can. Let's move on to example number 4. Find the value of C so that x minus 2 is a factor. That is probably the hardest type of question I can ask you about this entire unit test coming up here. Hardest question for this whole unit. What is the value of C so that x minus 2 is a factor? What does it mean to be a factor? I told you guys at the very beginning, but I didn't write it down. What does it mean to be a factor in terms of the remainder? The remainder has to be a certain number if you are a factor. Andres?
Pure factor, the remainder has to be 0.
The remainder has to be 0. So I'll write it down for the notes. X minus 2 is a factor of P of X if the remainder is 0. So we need to make sure that the remainder is 0, which means if I plug in a certain number, maybe I need to move this all up so I have some room to write. I need to plug in a certain number over here, and I should get out 0. I'm trying to boil this down for us. If I plug in what number, though? What number am I plugging in for each of these x's? What is it? Positive 2, exactly. If you switch sign, it turns into a positive 2. So I'm plugging in 2 for each of these x's, and then what I should get out is a 0. So I'm going to go ahead and set up that problem then. I should get out a 0. So I'll say I need a 0, and I'm going to plug in a positive 2. So C times 2 to the power of 3 minus 6 times, oh, what happened to my 6 there? 6 times 2 squared minus, and then 2 plus 2. And then I need to solve for C. All right, I have some more mental math coming your way. I need help. Someone help me. Help, help. I haven't heard from Gunnar or the girls. That's not math. I want to hear from Gunnar or Jenny or Josie.
What are we supposed to do?
Solve for C. Tell me anything I can do. Yeah, Jenny? What's going to be 8? 2 to the power 3? Yeah, I agree. So 2 to the power 3 is 8. I'll write it down. So I have 8 and still times C minus what? It's either Gunnar or Josie. 6 times 2 to the power of 2. Gunnar, go for it. 24, good, yeah, because 2 to the power of 2 is 4. 4 times 6 is 24. And then I'll just write down the minus 2 plus 2. Josie, you're up. And this is still set equal to 0. The right-hand side of that equation still needs to be simplified. Josie, for me, can you add -24, a -2, and a +2? So simplify, oh, they all add up to what? So -24, -2, and 2, they all add up to? Well, think about it this way, Josie. -2 and +2 adds up to what's 2 minus 2? 0, which means this -2 and +2 cancel each other out. You're just left with that -24. Thank you. So I ran out of room. I'm going to come back up here. I have 0 is equal to 8c minus 24. Everyone's in. Everyone can participate again. Still need to solve. Charles.
So to get to 0, we need positive 24. So we get to 8, 24, we multiply it by 3.
So you're saying C is 3?
Yeah.
You are indeed correct. Yeah, thank you. Can someone also solve it algebraically? Like what would you do to both sides type of thing? Jose?
Add on both sides.
Add what? At 24. And that's why Charles said you needed to get a positive 24. So 24 is equal to 8c. I do what next, Jose, to both sides? Divide by 8. Divide by 8. And you still get the same answer. C is equal to 3. And I'll box it. Thank you, Charles. Thank you, Jose. Yeah, so the answer here is 3. And you can see now why that is the hardest problem on our unit test, since this is our last lesson for our entire unit. You need to understand what the polynomial remainder theorem means to say, hey, if I plug in the opposite of this, I should get out a 0. Set that up as an equation, then solve the equation. It's not too difficult, but there are a lot of steps there in understanding of the polynomial remainder theorem. We have one final problem, then we're done.
Wait, no.
And I guess before I move on to example number 5, are there any questions on example 4? Please ask, because you're going to see this on your homework tonight. Questions? Question? Why?
So 3 is your final answer because you're trying to solve for C.
Yeah, so that means if I had 3x cubed minus 6x squared minus x plus 2, then x minus 2 would be a factor. Exactly. 3 is the answer that you enter into Khan Academy and you're done. Question, Charles?
Is there a way to do this with synthetic division?
That's a great question. I don't know. Let's try it. If I had synthetic division, I would have the coefficient, I would have 2 in the top left. I'd have C, -6, -1, and 2. I'd bring the C straight down. I get a C. C times 2 is 2C. 2C minus 6. Yeah. A 1, this number right here?
Yeah.
That is the coefficient though. C is the coefficient that we're looking for. And we know that that C should be a 3. So, and we have to be careful about what we mean by that. C is really a constant. It's a variable that represents a constant. X is a variable that represents a variable. So, but you're right. I understand the confusion. So 2C minus 6 is 2C minus 6. And then I have to multiply by 2. I get 4C minus 12. And then subtract the 1. So I get 4C minus 13. Ran out of room there. I would multiply by 2. I get 8C minus 26. I'd add the 2 and I get 8C minus 24. And that should be set equal to 0. And hey, 8C minus 24 is equal to 0. Yes, you can solve that with synthetic division. Is it easier? Is it harder? I think it's a little bit harder, but it's the same answer. And you get kind of the same boiled down equation too. Let's move on to example number 5. Select all polynomials that are divisible by x plus 1. That means that the polynomials must have x plus 1 as a factor. So I'm basically going to reread the same thing that I read up above. If I am a factor, if x plus 1 is a factor, then the remainder must be what number? Raise your hand or just show me. 1, 2. What number must the remainder be if x plus 1 is a factor? Hold up. Is it 1, 2, -1? Is it 0? Is it 5? Is it 10? Hold up number of fingers. What must the remainder be for x plus 1 to be a factor? Gunnar? 0. The answer is 0. The remainder must be 0. No remainder means I am a factor. We're trying to plug in a certain number and get out a 0. If we get out a 0, it is a factor. All right. So, who can help me with A? By the way, I should write down what I just said, huh? remainder of 0 means x plus 1 is a factor. Okay. What do I do for this first polynomial? 2x cubed, that one? Charles.
You put in -1.
All right, so I get 2 negative 1 to the power of 3 plus 7 times negative 1 to the power of 2 plus negative 1 minus 10. Help me simplify, Charles.
First one should be
Negative 2
-2. Second should be +7.
plus 7,
Third should be -1.
negative 1.
And last should be -1.
Yep, keep going, Charles.
Um,
Oh, question from Jade. We'll come back to you, Charles. Yeah.
What happened to the exponents?
Great question. Someone else answer that aside from Charles, because obviously Charles got this. So we had negative 1 to the power of 3. Where did that go? I just put out a negative 2. How do we get that? You get to call someone, Jade.
Well, like, we're multiplying those exponents now, so this exponents are representing -1 times -1 times -1. So now, we're
So
multiplying.
you're kind of just taking.
Yeah, got it.
And then I should also add as a quick rule of thumb, this thing. If you have any negative to an odd power, is that going to be a negative or a positive? Everyone give me a thumbs up or a thumbs down. Negative is down, positive is up. Everyone do thumbs up, thumbs down. Take a yes. Question, Andres?
Wouldn't it be negative -2 -7?
We'll talk about that in a second. That's the reason I'm going through these rules. It's actually a +7. A negative to an odd is a negative. You guys had it. What about a negative to an even? Give me a thumbs up or a thumbs down. Is it a positive or is it a negative? There's only 2 people voting. 3 people are voting. 4 people, 5, 6. Okay. It's a positive. A negative to an even is always a positive. What about a positive to an odd? Positive or negative? What's +2 times +2 times +2? Is that a positive or a negative? It is a positive. It's impossible to get a negative once I start with a positive. Positive to an even, therefore, is also a positive, which means the only case that you need to worry about, regardless of whether you have a negative or a positive, your base is a negative to an odd power. That's the only thing that will stay a negative. A -1 to an odd power of 3, a negative to an odd power, this negative sign stayed behind. It's still -2 from this -2. A negative to an even power, this negative to an even power turns into a positive, so it's going to be a +7. +7. Moving on. Charles, back to you. Simplify.
negative equal -11. Oh, wait, -13.
Okay.
The -13 plus 7 should be, I want to say 4, but it's, oh, it should be 6.
6 or -6?
Negative.
-6. And class, is -6 0? No, therefore it is not a factor. Factor is the word I forgot. You have to get that number equal to 0, and it is obviously not, which is kind of cool because I bet even if you were in that tough state that Charles was in, 7 minus 13, what is that? It's not 0, just stop, you're done. All right, let's go on to B. Who can help me solve for B of X? Jade, you're up.
3 times the quantity of -1 to the 3rd power plus 2 times the quantity of -1 to the 2nd power minus 3 times the quantity of 1 minus 1 equals -3 plus
Okay. Oop, my -2 is taking up too much room. Are there questions? What's your question?
I think Jade made an error.
Oh, I see.
Oh, what was the error, Jose?
It's, 2 times negative 1 squared. That's positive, that's positive 2.
Should be +2. Jay, do you agree or disagree?
I agree.
Yeah. So anytime you have a negative to an even power, should be a positive. Perfect. Yeah. Good catch, Jade. Continue on.
Five minus 5 is 0, so it is a factor of x plus 1.
There it is. B is one of the answers. And by the way, I didn't say in the instructions, I probably should have. Select all that apply. Just because we chose B doesn't mean we're done. It might be C and D as well. Let's check. Someone help me with C. Why it's up?
So you're gonna plug in a -1 for all of the x's.
-1, -1. All right, now what?
So that's gonna simplify to -2, -3, and 4.
Okay.
And then -2 minus 3, -5 plus 4 is -1. So C is not an answer. Possible answer.
All right, yeah, thank you. I have a question though. So Mr. Sindel said earlier that if I have a negative to an even power, that should be a positive. So this should be a +3. Why'd you write a -3? Yeah, why?
Because even though it's a positive, that coefficient is still a negative, so positive times negative is a negative, because it's a -3 times -1 squared, so it's still a negative.
Okay, yeah, so this is a positive in itself, but a positive times that original negative. Still a negative, I see, okay. All right, question? Andres, go for it.
This one's for A.
Yeah.
So how'd you get that blue?
How did we get the blue?
Yes.
So I think this was Charles' problem, right?
Yeah.
Yeah.
So Charles added up all the positives, it was just 7. All the negatives, -2, -1, and -10, -13.
Oh, okay. I thought that was different.
It's okay, yeah. There's a lot of different methods. It's hard to know what's going on for each of them. All right, part D, someone aside from Charles, Wyatt, and Jade. I'll do the first step for you. Plug in -1. That's the same step that we've been doing all along. I need someone else to help me out from there to just simplify some math. It's gonna be 5 times -1 to the power of 3 plus 8 times -1 to the power of 2 minus 19 times -1 plus 5 is what? Is someone to use my rules that I wrote over here on the left-hand side? That'll help us out immensely. Have I called on everyone yet? Have I called on you yet, Cohen? All right, Cohen, you're up. All right, and oh, I see hands. Yeah, Charles.
It should be a positive 19, negative 5, negative plus 1.
Negative and negative. Okay, now do you agree, Cohen? Okay, keep going, Cohen. Plus 24. Oh yeah, so -5 plus 8 plus 24. Yep, keep going. -5 plus 32. 27. And therefore, there it is. It was only B. Good job, guys. Question, Charles?
Well, this evening here, right, I guess, you could have just combined -5 and +5 and made it like 1 and 2.
These would cancel each other out from the very beginning. Yeah, that would have been a little bit faster, I agree. Any other questions? Andres?
Will there ever be more than 2 answers for exact point?
Yeah, there sometimes are.
I mean, more than.
Khan Academy does a better job than I do of saying how many to select. Sometimes they say, select one answer. Then once you find one, you're done with the rest. Sometimes they say, select all that apply, in which case you need to go through every single one and check them. Yeah, they'll say, if we just read the instructions. I just have bad instructions. Give me a fist of 5 on our objective. How well can you use this polynomial remainder theorem up here to answer questions about remainders and factors? 5, 4, 4, 5, 5, 5, 4, 4, 4, 4, 4, yeah. Question, Jade. I can, I forgot to do that, yeah.